In this last part of the topic, we'll be discussing about the Doppler's effect. So what does Doppler's effect stand for? Supposing you have a frequency, or if you have a source of sound that is producing any kind of frequency, if that frequency approaches the source or the observer, in that case the frequency changes, the relative frequency changes as a function of the velocity. Similarly, if it moves away, then the frequency decreases. So these types of things are characterized by the Doppler's effect. Doppler's effect exists both in the case of sound waves as well as light waves. Let's here characterize or try to understand about Doppler's effect in sound. We'll now move on to the next thing that is known as the Doppler's effect. So what does Doppler's effect stand for? Doppler's effect basically is there in the case of both sound as well as light. You would have often heard that there is this kind of blue shift, kind of red shift in the light that is coming to you. In a similar way, the same thing happens for the case of sound as well. So the sound, when we are talking about sound, so whatever is the apparent shift in frequency because of there being a relative motion of the observer and the source relative to the velocity of sound, that is what is meant by the Doppler effect. Yeah. So if I say that V is the velocity of sound that is in air, and Vs is the velocity of the source of the sound, right? Further, V0 represents the velocity of the observer. So there can be multiple cases when the source is at rest. You can have source in motion, you can hear the observer as at rest in both the cases, then you can have observer in motion either towards the source or away from the source. So effectively there are multiple cases that we are going to consider in this. So let's try to take it case by case. So what we'll have, the first one. So when we talk about the apparent frequency is the frequency that is observed under the circumstance when there can be an observer moving towards the source or away from the source. Similarly, the source moving towards the source or away from the source. So the apparent frequency is defined as follows. So this is how the apparent frequency is going to be defined. Further, if I say that the original frequency of the sound was this, V is the velocity of sound. So velocity of sound in air or the medium, and V observer is the velocity of the observer. Velocity of the observer with respect to the velocity of sound, either towards the sound or away from the sound. Then V sound plus minus V source, phase source which is producing the sound. So using this, you will take it like this. So if you take the source is moving towards the stationary observer, so the observer is stationary, so V observer is going to become 0. So when you are moving towards the observer, that means the sound and the source are moving together. So the relative velocity between them is going to be negative. That's the reason you have a negative sign out here. So the frequency is going to increase. When the source moves away from the stationary observer, by default they are moving in opposite direction, and therefore the relative velocity is going to be added up. And so the frequency is going to decrease, yeah, because this is there in the denominator. In other ways, if you take the observer moving towards the stationary source, obviously he is going to hear more sound, so that they are going to be added up. So it's going to be opposite to the velocity of the sound, so the relative velocity is going to be negative. If we take the next case, when the source and observer both move towards each other. So when the source is moving, so obviously the source is going to be moving along the direction of sound, the relative velocity between source and sound is going to be negative, and the observer is moving towards the sound, so the relative velocity is going to be added up. So that's the reason you will get this. When the observer moves away from the stationary source, you will get obviously is going to hear less, so the frequency is going to decrease, and the source is stationary, so there is no velocity of the source. Then if we have the final case, and the source and observer both move away from each other. So when we have both of them are moving away from each other, obviously you are going to hear less. So the sound is going to be moving in an opposite direction, and so this results in this. Finally, we have source moving towards the observer, but observer is moving away from the source. So as a result, these are all the cases. So if you just try to understand it logically, all the things would be very clear. In this last part of the topic, we understood about the Doppler's effect. So what does Doppler's effect stand for? Doppler's effect finds or tells you about the relative change in frequencies as a function of the velocity or as a function of the relative velocity of the source, the observer, with respect to the sound wave. So this was all about Doppler's effect. Please stay tuned for the next part, wherein we'll be discussing about the past few questions, past year questions on 5 topics based on the complete wave mechanics.